Hello, my name is Rich Howard, owner of Architectural Builder Supply, and this video is to bring you a closer look at the Dorma CP440 pivot. This video will serve as an overview of the pivot itself, some installation aspect, my personal opinions about the pivot, how I would go about specifying it, installing it, where I would use it. If you're familiar with the pivot, much of this is probably not going to be much new information to you if you've installed or made doors for them. However, that be what it may, hearing somebody else's perspective on it's usually not a negative thing. Also, if you're new to pivots, this video will serve as a remotely reasonable introduction to the Dorma pivot. So first of all, Dorma is a manufacturer, and I'm going to be referring to other documents here. If I turn my head away, it's on because I'm looking at something. Dorma is a comprehensive manufacturer of many things in the building hardware industry. They're multinationals, and much of what they sell doesn't apply to the domestic American market as it does to Europe. In the domestic American market, they have exit devices, lock sets, door closers, both overhead, surface mount, and floor. And then they have electromagnetic door holders, and then they have a comprehensive offering of pivot sets. And there's a link below this video to the product brochure, so you can review that to make yourself reasonably aware of what they manufacture. On page, at least at this time, on page 4 of the product brochure is a handy link. It's a chart that's a very good reference. And Dorma, they're smart the way they part stuff or in the way they name things. CP, center pivot. You can see that you've got some OP, and that's offset pivot. So we're looking at a CP440, and if you look over to the weight column, well, you'll see that that pivot is rated for 440 pounds. Now that's a very reasonable amount of weight that you could expect to have on a door. Unless it's a very unusual door, 440-pound rating is going to be where you'd want it to be. Of note, you'll have your CP660 and your CP1000. Okay, now, the CP440 in their center hung pivot is, quite frankly, their entry level. It's rated for that sort of weight. That's all there is to it. You might be building a bookcase, and a common application for these is such an application where you're doing a bookcase, but also the center hung pivots, the offset pivots as well. You might say, well, 440 pounds, that, if I were to take this 30-inch by 80-inch bookcase and load it up, you could easily get to 440 pounds. Some people might opt for the CP660, and there have been times I've sold the CP1000, where they know that the weight of the item is going to be substantial. Or, for these pivots, you're going to see them not only for the unusual bookcase application, but you'll see them on very wide doors. In the Southern California area of the United States, they do like their very wide entry doors on their homes. And I've sold the CP440 all the way up to the CP1000 for 5.5 foot wide doors where they're going to kick the pivot point in 18 inches or so, and while the door wouldn't nearly be that heavy, the client will say, I want something that's going to easily handle the weight, because you're technically using it in an application that is outside what it's been engineered and tested for. Unusual pivot point, door that is maybe perhaps wider than what it's rated for, etc. So there's lots of different ways to use those center hung pivots. Now, the CP440, the most common application is going to be a door where the client has said, I want the hardware to be concealed. I don't want to see it. I want it to be hidden. A center hung pivot certainly complies with that sort of requirement very well. And when the door is closed, unless your head is on the floor and you're looking at the bottom of the door, you wouldn't see anything. So of course, when you're doing a center hung, there are generally important machining notes to keep in mind when you're center hanging a door. You might have to radius or bullnose the edge of the door, and we'll talk more about that all a little bit later. So center hung pivots are used when you want concealed as well. Downside, though, of center hung pivots to keep in mind, because I've had to contend with this issue, is wood doors. Every wood door manufacturer that I'm familiar with is going to say in their warranty If the door warps, they're going to check for a number of things. One of the things they're going to check for is the door properly hung. A center hung pivot technically violates the definition of properly hung. They need to have a hinge or an intermediate pivot every so many inches, and with something at the bottom, at the top only, if that door were to warp at all, you'd have no recourse against the wood door manufacturer for warpage. So keep that in mind. Aesthetically pleasing, that's to be sure, but not necessarily something that doesn't have a downside for its upside. The rest of the product brochure, looking at it, what's handy is page 2, because it will give a definition of center hung and offset. And by all means, refresh or review that installation for the purposes of this video. And that bleeds over into page 3 of that. Then when you get into past page 4, you get into page 5, you're going to see all of the listing of the Dorma part numbers, all the way basically through the end of the catalog, and then getting into technical drawings showing individual components. So Dorma is really smart about the way they organize this stuff. And quite frankly, I wish I sold more of it. I wish I had cause and reason to get even more intimately familiar with their product line than I already am. I like their stuff. I wouldn't hesitate to specify it. I wouldn't hesitate to use it personally. Now, the CP440. Let's start at the bottom of the door, and we'll work our way up. So we're going to close the product brochure. We're going to fire up the template, is what it's called. Template for wood door. And we're going to pull that up now. The template for the wood door, and they also on their site have a template for their aluminum door application as well, if you're using it on an aluminum door. Starting at the bottom. Starting at the bottom would put us on page 3. Here is the business end of the pivot. And what people like about the pivot, and by the way, this is shown in the 626 satin chrome finish. What people like about pivots is, of course, again, the fact that they're concealed. You don't really see any of this stuff unless you were, laying on the floor. You wouldn't really see it. That is the portion that does all the load of carrying it. This is your floor portion. This is on page 3 is where we're at, the last page of the wood door template. I remember many years ago, 20 years ago, the first time I had to digest a pivot template, it just seemed to not make sense, as if it was drawn incorrectly. Well, the truth of the matter is, the longer that you stare at it, the more it becomes quite obvious that not only it's drawn correctly, but it makes perfect sense. And I've actually never found a template that was incorrect from Dorma about their pivots. The question becomes, how do you go about installing for the material? All right, now, the first thing you have to know is what sort of undercut you want to accomplish. And this is the part of the video where I'm going to talk about actually machining the door for it. Before we go into that, before we talk about machining / installation, to complete the overall view, if you're just a little bit interested about them, obviously available in several different architectural finishes, different screw patterns, different screw fastener combinations. By all means, let us know by indicating in the comment field what the composition is of the frame, what the composition is of the door. We would like to be able to supply the material correctly the first time based on the fastener that you are needing. Several different architectural finishes, satin chrome, all of the architectural finishes can be done. And if you have any questions about how to specify it, feel free to reach out to us. This part of the video, we're going to talk about installation now for pretty much the remainder. Page 3, first question becomes what is dimension A, the undercut from the bottom of the door to the floor, because that is directly related to how deep you mortise the bottom arm, which is here. And this package is for a wood door application. And your installation is quite obviously going to look just like that. Okay? You can see how large that bottom arm is. And it's large because it's rated for a high weight rating. Not only that, but you've got a sealed bearing packet that's in here. Well, to say that it's sealed, I don't know that it's sealed. I would say that it's not. Bearings are in there. All the weight of the door is going to be borne by Mother Earth. And that's what's nice about pivots. All the weight's translated right down to the floor. Okay? That's what your installation looks like. So the question becomes is how deep do you mortise this into the door? And that is based on what undercut you want to achieve. So how far this gets cut into the bottom of the door will affect the undercut. So if you are, first of all, always with pivots, always look at the notes. The notes are the instructions. And in many times you really won't get instructions with a template, or pardon me, with a pivot, just a template. And quite frankly, it's all pretty much there. It is all there, actually. Notes, do not scale the drawing. Yes, that's true. Dimensions are shown in inches, millimeter. Now, note 3, and this is template number LM-29, last revision August 2nd of 2004. Dimension A is the dimension from the bottom of the door to the floor. See note 3. Dimension A is the distance from bottom of pivot to bottom of arm. When bottom arm is installed to the standard template, this is also equal to the bottom door clearance. That's a hard, roundabout way of saying that the bottom of the door is the bottom of the arm to the floor. Now, dimension A is pulled from that column. Spindle size is important to know that should you have an instance by which you need to accommodate an unusual undercut, and we're going to get back to the actual machining dimension in a moment. Let's say you had a requirement that you're going to install a 1/2 inch threshold over this. You would need to have that spindle made custom and extended so that it could reach the bottom of the door, because you didn't want to have to surface mount this to the bottom of the door. It could be a condition that you need a longer spindle to be manufactured. So when you've got a condition by which you're going to have an 11/16 dimension, you're going to be working with the standard spindle size. Moving forward with how to prep the bottom of the door is found on page 2. So, page 2 is going to give you, first of all, the mortise depth based on the clearance. Page 2, lower right-hand area. So your clearance is in that center column. Okay? And 3/4 inch clearance is pretty common, the smallest clearance. You can see, so the way that this is being accomplished is whatever your clearance is, that is going to be related to the mortise depth. However, with the Dorma pivot, you'll see that as the clearance changes, your mortise depth doesn't change. What does change, though, is the length of the spindle. Longer spindles are available. They have to be factory ordered. They have to be ordered based on the clearance that you want to have, and the table will give you the longer spindle. That information can also be reviewed in the product brochure. If you were just to search that product brochure for extension, you'll see the table that tells you what you need. Now, if you needed to accomplish a smaller clearance than 3/4, what people do is they just mortise it all deeper. So if your mortise depth was 23/32, almost an inch, closer to 7/8, and you needed to decrease that clearance to 5/8, you would increase your mortise depth that 1/8 of an inch. Okay, so you're going to be 1 1/32 sort of thing. So you can cheat it that way as well. Now you could also cheat it the other way and not mortise the item as deep into the bottom of the door, obviously exposing a bit of this. You know, the less you mortise this, the more you're going to expose of this. You could easily get that down to here, I suppose, without any trouble at all. So you could accomplish if you were to flush this off to the bottom of the door, there is not a dimension given for that, but you would be at about 3/8 of an inch. So you could turn that clearance into 3/8 of an inch itself if you were to flush this to the bottom of the door, and this would be sticking out of the bottom. So you'll need to do this math yourself to make sure it works for you, but that is a possibility. But the proper way is that you just alter the spindle, is how this is done. And quite frankly, that's the way that it's been tested for 440 pounds. If you're going to use it in an unorthodox fashion, definitely keep in mind that it was engineered, it was tested based on standard installation situation. So page 3 gives you the important note regarding the jamb to the vertical center line of 2 3/4. Gives you the 1/8 of an inch clearance there. Now, that is going to be based on quite important to know. That is going to be based on the detail that you see on page 2 that shows you that radius. You've got an 1/8 of an inch when the door is radiused. That's all there is to it. If the door is not going to be radiused, then it's not going to work with an 1/8 of an inch clearance. The amount of radius is directly related to the door thickness, so you have to have a proper radius. You can see how that and that radius applies whether you're doing a double acting or a single acting application. If your door does not swing both ways, then you would just bullnose. You would do half of that preparation. You could leave the other side square, or the push side of the door square. Looking at page 2, not anything of significance in the notes except that everything has to be reinforced. You have to have a proper door bottom to mortise this to. You couldn't mortise it to just particle board. You'd have to have solid lumber down there at the bottom of your door, or a metal door or an aluminum door made specifically with reinforcements for it. So you're given all of the dimensions on where this needs to be. Okay. You're not given the radius of this corner that I can see. I'm going to say that if you're using a 1/2 inch diameter 2-flute carbide router bit for routing this out, that you wouldn't have to square those corners much at all. It's just not given specifically. What I don't love about this template is the fact that I have to refer to the center line of something. Meaning, where do you place this laterally in the door? Well, you know that it's in the center line of the door because that dimension is given, and you're told 15/16. But where do you place it off the edge? You can see the center line from the jamb to the center line of the spindle is 2 3/4, and doing this kind of work is much easier when you have a caliper, so that you can really get fine with the location of where this is in the bottom of the door. The dimension of this is critical to be accurate because you don't have an opportunity to change it after it's mortised. It's not easy to change where this is all placed. It needs to be accurate, is the bottom line. We'll talk about the top pivot a little bit, and the top pivot is a very smart piece of hardware that it will give you the ability to tip the door to accommodate. But this needs to be straight. This needs to be plumb. This needs to be accurately located, as does this. So if you have a caliper, you're going to be in pretty good shape because you can determine the size of this, take half of it, add your 1 3/8 as it's shown there, deducting all that off of 2 5/8 if you're going off the edge of the door, and determine your mortise at that point. You can see 1 3/8 plus 7 7/8. You got 9 1/4 overall length on the arm, 15/16. It gives you does not give you a thickness of the arm because it's assumed that that's not critical because you have your mortise depth there. Okay. Now I had said earlier about telling us the composition of the door and frame. This is going to a client that has a metal door, and all they sent were machine screws. So if you've got a wood door, that won't work for you. So be sure to clarify that if you can. So back to the mortising of it. I would use a router. It would be the only way that I would do this. If I had one to do and I didn't have a template made, you could get by doing it by hand, but you really need that to be a flat bottom preparation, and a router is just the best way to go. If you want to discuss how to go about routing the wood door for this, feel free to reach out to us. But there are companies that make templates, and if Porter Cable is one. Template guides. If they don't have something that will work, or you can't get your hands on one, you end up making your own. A piece of wood that you can attach to the bottom of the door that takes into account the diameter of the collet, and etc. is how you'd go about doing that. So it's centered in the bottom of the door in terms of the thickness. You've got your dimension from the jamb or the edge of the door to the center line of the pivoting axis. Crucial that that's plumb. You've got your mortise depth. You mortise it. You attach it. You're in good shape at that point. Your bottom portion is done. And by the way, you've already located this on the floor. It does include screws and anchors. Okay. Now, continuing to work our way up gets us to the top of the door. Now, the top of the door looks a little bit more complicated than it ought to. But that's just a temporary setback, really, in terms of thinking about it. The top of your door is going to have two plates. It's going to have this plate, and then it's going to have the other plate that has a bearing assembly, bushing assembly in it. This is an open-ended situation, and this has got a hole that's tapped in it. That's the hinge side of the door, or the side towards the would be the hinge jamb. That plate's going to rest in there just like this. Exactly what that's supposed to look like. Needs to be oriented this way, not this way. Now, looking at page 1 of the template, you're going to see about in the middle of the template, bottom half really, where all this is going to be getting installed. Again, it's crucial that you have 2 3/4 inch from your jamb to the vertical center line of the pivoting axis. You're going to have at the bottom of page 1, top view of the door portion, you're going to have that dimension that shows you 2 3/4 from the jamb, and then to the edge of your preparation of this plate, 1 9/30. So 2 3/4 less 1 9/30 is where this starts. You then can obtain your overall length. You can then, from the drawing above it, obtain your thickness of the material, which is 7/16 for this. The width of the item is given at 1 5/30. So now you can basically route yourself this rectangular mortise in the top of the door. Now, this piece is going to fit loose in here for now. Let's move on to the rest of the frame portion. What I mean to say is there's more to discuss the door portion, but I want to get the top portion talked about first. Here's your top assembly. Okay, this is really it, except that you're going to get a cover plate. Okay, and that's just going to cover you off here. Now, this is a really smart piece of hardware from Dorma. Much less common for my experience for pivots is the fact that in the upper right hand corner you've got a table called door clearance, a reference to position A, B, and C, standard pin 1/8, 3/8, 3/4, an extended pin, etc., etc., etc. Now, what that means is that this top pivot can accommodate an 1/8 of an inch margin from the underside of the header of the frame and the top of the door. It can accommodate a 3/8 margin, and it can accommodate a 3/4 inch margin. Now those 3/8 and 3/4 inch margins, admittedly to me, are a bit unusual. However, this pivot can handle it. This bolt here has 3 positions, and you can see one of them here. You may have to adjust the position, as you can see in the cross section, several inches below that first door clearance table, where the A, B, and C positions are called out. In order to change the position, you're going to remove this screw, and do not lose it. This will not be something you can find at Home Depot. You're just going to remove it. Control everything. Don't let things go flying on you. Nothing's spring-loaded. That bolt's going to come out. At this point, you can kind of unthread that. Quite frankly, you can just remove it at that point. Luckily, it wasn't glass. You've got these 2 finger pins, and then you've got your spindle. A and, well, let's see here now. C, B, and A positions. So if you're going to go with the typical 1/8 of an inch, you're going to go into the A position, which is the lowest one. So you're going to insert that back into there. You're going to take your 2 finger plates, get them stuck into that bottom position there. Okay. You're going to fall into there like that. Come back in with your bolt and maybe just hold that up a little bit and get it to mate together. And just start to thread it back together. Now, the last thing is to put that shoulder bolt back in there to hold it all together. You're going to have to adjust that a little bit to get it to be exactly where you want. Then come back with your screwdriver. Doesn't have to be excessively tight, just hand tight. You probably have to loosen the parts to get the screw to continue, just hand tight. And now we've got that set in the A position. That bolt controls how far that thing comes in and out. And you got to have it in the right position, otherwise your installation will fail. And I'll say that in a moment. So right now the pin's all the way extended because that bolt is flush. When we loosen it to withdraw it, to retract it in, that's what it looks like. So you're going to have these top plates attached to the top of your door. This will be up and attached into the header of your frame, and I've had people try to install these. They didn't want a frame at all. They just want drywall. And I say, well, what are you going to chisel this to? Oh, there's a 2x4 stud up there. I'm just going to cut a hole in the drywall and make that work. And I know people have done it, but I've got to think that's a maintenance issue down the road. You're going to want to have solid lumber up there. Absolutely. No questions asked. And then when this is installed, you're going to tip your door like this and get it into the opening. Then cock the door open and then take your screwdriver and drive that pin down until it's flush, and that's your installation. You can see why it has to be in position C, or pardon me, A, if you've got an 1/8 of an inch margin, because if for some reason you had a 3/4 inch clearance, you'd have to go to that other position so that this can fall, so that this can project down much further. So your final installation is governed by this bolt here. Okay, you can only get that up and down when the door is in the open position, because otherwise this bolt would be in the way. Then of course you have your cover plate that's going to dress all that off and make it look super duper. This has a white peel away protective film on it, that's why it looks that way. Now, back to this doodad, this door assembly. What I really like about this is this top pivot, this top door portion of this pivot door portion of the top pivot to laterally adjust, which is governed by a set screw that is here. You thread that in there, and you can force that to go back and forth. You can see here there's a provision for a screw, and that is that round head bolt right there with the blue Loctite on it. So if you know that your bottom is accurately located, 2 3/4 off the jamb, centered in the door, your door prep for the bottom spindle is spot on, you're going to be in great shape. You can then not be as critically worried about being a 1/16 of an inch off with your top portion, because remember, it has to be plumb, because you can then take this via that set screw and take that door and force it to tip ever so slightly in and out, because you got a margin between the jamb and the edge of the door. That straight line you'll be able to see a million miles away, if it's not, if the edge of the door and the frame aren't parallel. They need to be utterly parallel. So after you get that margined, you can come in and tighten your plate down, and you're done. Your installation is complete at that point. Again, the top pivot came with wood screws and machine screws. Let us know what you need so that we're reducing the opportunity for something to not be correct. Looking at the rest of the template for the top pivot, you can see the side view, how they've got that U-shaped prep in the edge of the door. That I'm not a fan of. I don't like that at all. It's unsightly, to say the least. Although it's tiny, 3/8 by 5/16. I might be tempted to overshoot my mortise on the top of the door so that I could come in potentially with a L angle sort of screwdriver if you had the right tool to do that. You may not. If you didn't, you got to make that U-shaped prep in the edge of the door so that you can access that set screw that's going to be here and connect here, driving that, controlling that. Notes, we should have discussed those first. Do not scale, dimensions are in inches, millimeter, all necessary reinforcing for pivots by others. Pivot pin diameter is basically 9/16. Pivot pin projection is adjustable. See the chart for door clearances, we discussed that. And really the only other thing that I think of that we are not discussing thoroughly is how to radius or bullnose the door. In order to achieve that tight margin, you've got to have 1/8 of an inch. And that's going to go for the lock side as well, if it's a door that will swing in and out. If it's a pull side only, if it's a single swing door, a single acting door, you can just put your typical 3-degree bevel on it and you're good. The problem with radiusing or bullnosing doors also, if they're veneer construction, and this industry is like the school of hard knocks, you do kind of learn the hard way. Veneered architectural doors, architectural wood doors, are veneered. When you look at the 1 3/4 thickness of a door, when you put your 2 3/4 inch diameter roundover bit into your massive router, and you take that square edge door and you round it over, you're going to accentuate your seeing of the layers that make up the door veneer, the plywood that is the door veneer. As you cut through the door, you're going to accentuate the layers. Doors are typically made of plywood. You'll have your veneer, your crossbanding, and your backer, and that plywood is typically 1/8 of an inch thick, about, glued down to the core. So those 3 layers that make that plywood up, as you cut through it this way, you accentuate those lines. So let's say you've got cherry doors and cherry styles. The veneer is cherry, The crossbanding is not. The backer is certainly not cherry, and the style will be cherry. But you're going to see these lines that are going to be there. So keep that in mind as you're manufacturing these doors. A lot of people who do this kind of work are also going to already know that that is an issue, and they'll use a product like No Black Line, and they'll wrap that entire face of the door and come back over the style and wrap and veneer everything so you don't see any of it, which is a very common way of doing it as well. But keep in mind, that's what your mortise is going to be like, in terms of, pardon me, your radius is going to be like. If it's double acting, you've got to have a full radius on both styles, which is very common as well. But if it's single acting, you'll do a bull nose, which is like the top row of tile in your bathroom, and then just a 3-degree bevel on the other side. Then typical hardware in these instances usually are edge pulls and roller latches are typical things. That pretty much sums up everything I wanted to say about Dorma. I am a fan of Dorma's. I've been a distributor of theirs for many years. I have come to rely on their customer service contact I have there, who is extremely responsive, and their technical support people there are spot on and responsive, and you can't ask for anything else. Like I've said at the beginning of this, I look forward to having more opportunities to sell Dorma material that requires a deeper, more intimate understanding of their product line. I like pivots. I like Dorma. Any questions, please feel free to reach out to me. My name is Richard, owner of Architectural Builders. Thank you.